How about a little practical application of logarithmic functions? In this case, we're talking about, we have a logarithmic function that's dealing with computers being infected by a virus. The number of machines infected by a specific computer virus can be modeled by C of D equals 6.8 plus 20.1 times the natural log of D, where D is the number of days since the first machine was infected. And then we got three questions here, and we're going to solve these on the calculator. But how many machines were infected on day 12? Well, all we really got to do here is substitute 12 for D right there, and we can solve that. And then the next one is how many more machines were infected on day 30 than on day 12? Well, we're going to substitute 30 for D, but then we're going to take that, whatever answer we get there from this function equation, and subtract it from what we found on day 12. That's going to have how many more. And then I'm going to show you a couple of ways that we could find the number, about what day will the number of infected machines reach 75. So let's proceed to the calculator and just work our way through this, because we're mathematicians. All right, so we've got C of D equals 6.8 plus 20.1 times the natural log of D. D represents the number of days, and first we're going to put in here for 12. So I'm going to just, let me quit out of here. Take me to my math screen. Let me clear that. I don't know what I was doing there. So let's go see. We got 6.8 plus 20.1, yeah, 20.1 times, well, let's try it this way, times the natural log of 12. We're going to substitute 12 days in here for D and hit enter. And let's see, 56.7, let's say 57, we're going to round that up to the nearest whole number. 57 machines have been infected by day 12. Now, how about how many more from day 30 to day 12? Well, we got to find day 30. So again, I'm going to go 6.8 plus 20.1 times the natural log of 30. Okay, how many days, how many are going to be infected on day 30? Well, if I round that to the nearest whole number, it's 75. And then if I take 75 minus 57, that should give me how many more have been affected. Well, Shazam, that's going to be 18. Then it says, on what day was the number of infected machines reach 75? Well, actually, we found that the first time, we just kind of lucked into that, by 30, okay? But, because that 6.8 plus 20.1 times the natural log of 30 is 75 machines, so really it's day 30. But let's say I didn't have it like that. What could I do? Well, now I would have C of D equals 75 machines. And let's first subtract the 6.8. Subtract 6.8 from both sides. All right, that's 68.2. And then let's divide that by 20.1, which would just leave us with ln of x. Divide by 20.1. So that equals 3.39. Now, I'm left there with ln of x. But remember now, this is a logarithm, and so it's the inverse of an exponential. And so its inverse would be the natural base e raised to this power of 3.393 0.0342826. So if I substitute in the natural base, and I'm going to hit second ln, which brings up e, and I want to raise it to this power that I previously found, so I'm going to hit second answer, and that puts in that as an exponent. And let's hit enter, and I hope I'm going to get somewhere near 75. Near 30, excuse me. 29.756, and if I round that to the nearest whole number, that also would be 30. How about that? Shazam.